All right, today we're going to start talking about why we factor in the first place and one of the purposes behind it. So let's take a moment and look. We've been working with trinomials to the degree of 2, which remember we called quadratics. All right, so I'm going to graph these two right here. They're both trinomials in their degree 2. So this is what their graph would look like if we were to graph them. So one of the reasons we factor is we can use that factor to find the points where they cross the x-axis. So our x-intercepts. Okay? So that's one of the things that factoring is very useful for. Now, one of the things that lets us do this is our zero product property. So if a times b equals 0, then a equals 0 or b has to equal 0. So again, this is where factoring comes in. We can, if we've already got it factored, we can solve both of those, or we can factor and then figure out x is either one number or the other. So looking at this property just basically says I can set x plus 2 equal to 0 or x minus 5, because one of those two parentheses has to be 0 in order for the whole thing to work out where x is 0. And I can simply solve those, right? It's a one-step equation. Minus 2 here, and I get x is equal to a negative 2, or add 5, and x has to equal a positive 5. So either x is negative 2 or x equals 5. And a lot of times you'll see our answer written with the curly brackets as negative 2, 5. Okay, so let's look at another one. Got 2x minus 2 times 5x plus 8 equal to 0. Oops. So I get 2x minus 2 equals 0, or 5x plus 8 equals 0. Now this one takes a couple more steps just because of we've got a coefficient in front of x. So add 2 to both sides here, giving me 2x equals 2. Then divide by 2, and we get x is either 1 or minus 8 on both sides on this one. And I get 5x equals a negative 8, and divide by 5. So then we get x is equal to negative 8/5. So we either have x equal to 1 or we have x equal to negative 8/5. All right, so what if we're not already in factored form? Well, we can very easily put these into factored form. So first thing I want to do is I want to factor that. So setting up my 2 parentheses. Okay. Oops. All right, so we've got 9 as my C and negative 10 as my B. So we're going to look for factors of 9. Well, 9 has only a few, 1 and 9, 3 and 3. And we're looking for the factors that add to a negative 10. Well, since our C is positive, we know that either both factors are positive or both factors are negative. Well, in this case, both factors have to be negative because B is negative. All right, so which of these add to negative 10? Well, that would be the negative 1 and negative 9. So we get B minus 9 times B minus 1 equal to 0. Now I have it in factored form. I get B minus 9 equals 0, or B minus 1 equals 0. Okay, so add 9 here. I get B is equal to 9, or I get, adding 1 on the second equation, B is equal to 1. So either B equals 9 or B equals 1. All right, let's do another one. We got to factor this. So we're looking for factors of negative 54 that add to 3. So let's start with 54, factors of 54. Well, 1 and 54, 2 and 27. 3 and 18. 4 doesn't work. 5 doesn't work. 6 and 9. 7 doesn't work. And 8 doesn't work. All right, so there's my factors. Now, since 54 is negative, only one of my factors is negative. And since b is positive, that makes the smaller negative. So which of these is going to add to 3? Well, negative 6 and 9. So we get c minus 6 plus 9 equal to 0. So we either get c minus 6 equals 0 or c plus 9 equals 0. So adding the 6, I get c is equal to 6. Minusing the 9, I get c is equal to negative 9. So c is either equal to 6 or c is equal to negative 9. All right, we're going to do 2 more, and then we'll be done with this. So we're going to look at factors of negative 22 that add to 9. So factors of 22 are 1 and 22, 2 and 11, 3 doesn't work, 4 doesn't work, we know 5 won't work, 6 doesn't work, all right, so those are the factors of 22. So which of these add to 9? Well, since 22 is negative, again, one of the factors has to be negative. So we know the smaller since b is positive, and 11 and negative 2 are the only ones that would add to positive 9. So we get f minus 2 times f plus 11, and that's going to equal 0. So either f minus 2 equals 0 or f plus 11 equals 0. So add 2 to both sides, and I get f is equal to 2, or we can minus 11 and get f is equal to negative 11. All right, we're going to look at one last one. And so we talked about this is a special case where that middle term is 0. So we're looking for factors of negative 25 that add to 0. So factors of 25 are 1 and 25, 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 works. So since negative, one of my factors has to be negative, I'm going to make this smaller. And the only ones that add to 0 are negative 5 and 5. So we get g minus 5 times g plus 5 equals 0. So either g minus 5 equals 0 or g plus 5 equals 0. And again, solving these, either g equals 5 or, oops, I forgot my equal sign there, or g equals a negative 5. All right, that's all I have for you in this video. I will see you in the next.